I am going to now do the video for the homework, and this is the worksheet that I gave out towards the end of class, so just going through step by step for this. All right, so we're starting off with number 1, and if you look at number 1, you have it separated in 2 parts. Of course, my pen is not working. There we go. We have it separated into 2 parts, before and after. So let's find the momentums before. This object right here has a mass of 2 kilograms and is going at a velocity of 5.2 meters per second. This mass, or this object, has a mass of 13 kilograms and it's not moving. So let's do the momentum of this one first. For this one, momentum equals P, or M times V. Okay? We put those in. You have 2 times 5.2. So your answer is going to be 10.4 kilograms times meters per second, and you're going to the right. Okay? Now this one, since it has no velocity, its momentum is going to be P equals its mass, 13, times 0. So its momentum is equal to 0. Add the 2 of them together to get the total momentum before, and your total momentum would be 10.4 times plus 0, which is 10.4. Now, we have to figure out what the velocity of the combined masses is after the collision. All right, well, the combined masses have a total mass, which would equal to 15 kilograms. Their momentum, their combined momentum, thank you, Bill, their combined momentum is going to be equal to the combined momentum of before, so that is, the total momentum is still 10.4. So if P equals 10.4 and mass equals 15, we can solve for V by dividing it by 15. And the answer is, I believe, 0.69 meters per second to the right. Okay? All right, let's move on to the next question, number 2. And of course, if you have questions on these when I go over, as I'm going over it, write those questions down and ask me in class tomorrow. Okay, so in this one, we have 2 momentums and 2 velocities to start with. So let's start with this one first. Momentum again is, okay, so for this one right here, my mass is 3, my velocity is 6, so my momentum for this first object is 18 kilograms times meters per second, and it's going to the right. I'm just going to abbreviate right as RT. This one has a mass of, and I'll put it up here, 10, a velocity of 4, that's a 4. So its momentum is 40 kilograms times meters per second, right. Okay? We take this and we take this to figure out our total momentum before the collision. So that is 58 kilograms times meters per second to the right. So now we look at after the collision. After the collision, they stick together, so they're one mass. That single mass is equal to 13 kilograms because I add 3 and 10. Okay? Now the momentum before was 58 kilograms times meters per second, or kilograms times meters per second going to the right. So the momentum after should also be 58 kilograms times meters per second to the right. So momentum equals mass times velocity. We have 58 equals 13 times V. Divide both sides by 13. I didn't have this calculated before, but I will come up with it right now. 58 divided by 13 equals, I'm going to round to just 1 decimal place, and it's 4.5 meters per second to the right. Again, if you have questions, ask me in class. Let's go to the next one. Okay. Very similar to the one we just did. I'll put everything over here. So before, we have before momentum. Here's momentum. Okay. My first mass has a 10 kilogram mass, and its velocity is 6 meters per second. So my momentum is 60 kilograms times meters per second to the right. Sorry for that weird pause. Okay, so let me start over with this slide. I think I erased some things. Or am I just starting? I'm sorry. Here we go, guys. My mistake. All right, so before, go back. P equals m times v. So we have a mass of 10 kilograms and a velocity of 6, or 10 and 6 right here. So your momentum is 60 kilograms times meters per second to the right. Okay? The next mass, we'll figure out for that one, so I'll just put a line here. And we have the momentum of that as being 3 kilograms times 3 meters per second, kilograms times meter per second. And that's going to equal 9 kilograms times meters per second, also to the right. These are both for the before part, so these are the two momentums right here. So you add these two together. Your total momentum before, total before equals 60 plus 9, which is 69 kilograms times meters per second to the right. Okay? So that is your total momentum for before. That is going to be equal to your total momentum here. So you know that P total is going to be 69 over here. Okay, so just to make things a little easier, I'm going to get rid of this original stuff. Okay, so we have the momentum of this object right now after the collision. Momentum is mass times velocity. We're doing after. So the momentum of that one is going to be, P is going to be equal to the mass, which is 10, times V, because we don't know what velocity is yet. For the second one, momentum, also mass times velocity, is going to be equal to 3 times 9. So that's 27 kilograms times meters per second. So this momentum plus this momentum has to equal 69 because momentum gets conserved. So I set everything equal to 69 kilograms times meters per second to the right. I take 10V, add that to 27. Okay, I want to get like terms together, so I subtract 27 from both sides. That cancels this out. 27 here. Okay, I don't think I have enough room, so I'm going to have to redirect. So this is going to be 42 is equal to 10V. Multiply both sides, divide both sides by 10. We have 4.2 meters per second right as your velocity. Okay, move on to the next one. Oh, I actually started number 3 but didn't finish it. Sorry, guys, when I was interrupted. All right, so pretty much similar to the one we just did. You have 60, your other momentum was 3 times 3, which is 9. So your total momentum before was 69 kilograms times meters per second to the right. After, oops, that was weird. After, the mass is a total combined mass of 13, and velocity we don't know. But we know momentum to be 69, so we take 69, set that equal to 13 times V, divide both sides by 13. And I'm not trusting my math skills right now. 69 divided by 13. Your velocity will be 5.3 meters per second to the right. Okay, so you've gotten 4 done. Number 5. This one's going to be a little bit more complicated because you have them going in opposite directions. So, momentum of this one. So we're doing momentum of this one first. Momentum is equal to 3 times 3. So this one is 9 kilograms times meters per second to the right. The next one is also mass times velocity. So P in this case is going to be 2 times 2. And that gives you 4 kilograms times meters per second to the left. Since they are not going in the same direction, you now have to subtract instead of add to find your total momentum before the collision. So it would be 9 minus 4, which gives you 5 kilograms times meters per second, and since 9 was the bigger one, that's the direction you go to. This is just like net force. I'm hoping you guys hear me with this, because I'm thinking I'm really, really soft. I hope it comes through. All right. So that's the momentum before, 5 kilograms kilograms times meters per second, right. Okay, so afterwards.
Would Ethan Silver please come to the front office now? Thank you.
Regardless how loud I am, you probably heard that. Okay. Afterwards, momentum of this object, so that is going to be mass times velocity. That momentum is going to be 3 times v, so we're just going to remember that as 3v. For this one, line here, this momentum is going to be 2 times 4, 2 times 4, which is 8 kilograms times meters per second to the right. This one is actually going left, so you're going to have to subtract it. Okay, so my combined momentum for these two would be 8 minus 3v. Since momentum is conserved, 8 minus 3v has to equal 5. All right, get like terms on the same side, and you get negative 3v equals negative 3. So v is equal to 1 meters per second to the right, because that's our positive direction. Okay? I really, really hope this is working. And the last question. Well, you know what? This last question, I hope you guys are able to do. Nah, I'll still do it. All right. For this one, P equals M times V. You have P equals 3 times 6, so P equals 18 kilograms times meters per second to the right. For this next one, so we'll just go underneath, P equals M times V, and this is equal to 5 times 4, which equals 20 kilograms times meters per second to the right. Since they're going in the same direction, you add them together to get your total. Total P. Oops, I don't know why I'm doing that. Let's get rid of it. So that is going to be, your total momentum is going to be 18, come up here, plus 20. So it winds up being 38 kilograms times meters per second to the right. All right, so that is your before, 38. Just writing it there for safekeeping. For after, momentum equals velocity. 3, so we're doing this one first, 3 times 3.5, and that is going to give us 10.5 kilograms times meters per second to the right. For the second one, P equals M times V. We don't know what P is just yet, but we can figure it out. P equals mass, which is 5, and velocity, which is V. Okay? Now, I'm going to do this the other way, opposite of, not opposite, but different from the way I did before. If your total momentum is 38, and the momentum of this object was 10.5, you can subtract them to find out what the momentum of this one is. And you get 27.5. So 27.5 equals 5v. Divide both sides by 5. And you get 5.5 meters per second to the right for your velocity. Hope it actually made an audio clip with this, and we're just about 15 minutes, so I'm stopping there. Any questions, you ask me in class tomorrow.